Alright, this is the third video in our lesson on graphing rational functions like these. In this video we're going to do problem number 7. First, the x-intercepts. How do we find the x-intercepts? We set the numerator equal to 0. So x squared equals 0. Square root, that's going to give us x equals 0. So that means the x-intercept is 0, 0. Now it's time for the y-intercepts. Alright, y-intercept. How do we find the y-intercept? We substitute 0 for x. Alright, if I substitute 0 for x, then I'm going to have 0 squared over 0 squared minus 4. Alright, of course 0 squared is just 0. Alright, and 0 minus 4. So this is just 0 over negative 4, which is just 0. Okay, so that means my y-intercept is also 0, 0. Well, both of these are the same point, so it makes sense. The graph will cross the x and y-axis at the same point. Alright, how do you find the vertical asymptotes? To find the vertical asymptotes, you need to set the denominator equal to 0 and solve. So in this case, I'm setting x squared minus 4 equal to 0. I could add 4 to both sides and take the square root, or I could factor. So x plus 2 times x minus 2. Alright, so that's going to give me vertical asymptotes of x equals negative 2 and x equals positive 2. Okay, so vertical asymptotes, x equals negative 2, x equals positive 2. Alright, how about the horizontal asymptote? Well, remember, the horizontal asymptote, that's the one where we have to consider which one of these three cases we're in. It's all about the degree of the numerator and denominator. If the degree of the numerator is less than the degree of the denominator, it's y equals 0, the horizontal asymptote. If the degrees are the same, then we do y equals a over c, where a and c are the leading coefficients. And if the degree of the numerator is greater, then there is no horizontal asymptote, though there might be something called a slant asymptote, which we'll talk about another time. So which one of these three situations are we in? Well, as I'm looking for the degree, both of these have the same degree. Alright, this is degree 2, and the denominator is also degree 2. So if the degrees are the same, then we do leading coefficients. Okay, and the leading coefficients here are 1 and 1. Okay, so horizontal asymptote, y equals 1 over 1, which equals 1. Okay, so let's graph these three asymptotes, alright? A horizontal asymptote at 1, and these two vertical asymptotes at negative 2 and 2. I'm going to do that off camera. Alright, so here are the asymptotes that we discussed. So, next, before we can do the domain and range and all this, we need to get our table of values going. So here's how you pick the values. Look at your vertical asymptotes. Alright, we're going to need values in every part of this graph. So we'll need a couple values to the left of the first asymptote. So the first integer to the left is negative 3. So I'll definitely do negative 3. We also want to see what's happening very close to the asymptote. So we're going to have to get into some fractions and decimals. So let's do negative 2.5 to see what's happening close up. So negative 2.5. Now, we also want a value or two just to the right of this same asymptote. So let's again use a decimal so we can see what's happening really close to the asymptote. So right here on the right hand side, but just barely, would be, for example, negative 1.5. Okay, use those decimals, so negative 1.5. Alright, moving on over, the first integer I have in here is negative 1, so let's definitely do that so we can get a better picture of what's going on over there. So negative 1. Okay, we already have 0, 0, so we don't need to add that to the chart as well. But let's look and see what's happening at positive 1. Okay, and then let's look at, again, very close to the asymptote. So let's take a look at 1.5. Okay, which would be right in here, 1.5. Okay, now let's hop over the asymptote, but still stay very, very close to it. That would be 2.5. I'm very interested in that. And I would actually add on one more value. Go ahead and get that first integer. It will be 3. So let's go ahead and take a look at that. So I would use all these values. Alright, again, we needed every part of this graph to the left of the asymptote, to the right of the asymptote. And then we need to make sure that in between the asymptotes we have plenty of values. We have the middle, but we should have at least a value to the left and to the right. But also, and this is what a lot of students will forget, strange things can happen as we get very close to the asymptote. So if I were you, I would use decimals just on either side of each one of these. So negative 2.5, negative 1.5, positive 1.5, 2.5, real close on either side. Alright, so we can put this function into our calculator and check out the table of values. Okay, so we'll hit that table button, clear that thing out of there. So we have x squared over x squared minus 4. So x squared over x squared minus 4. So we can scroll around here as much as we like. I'm going to scroll around and get all of the integer values, so 3, negative 1, 1, and 3. And then I'll worry about the decimals later. So for example, negative 3 is 9/5. Okay, toggle that, that's 1.8. Okay, at negative 1, we've got negative 1/3. I think I'll just leave that negative 1/3 because I know what that looks like. At positive 1, we've got another negative 1/3. Okay, I'll do the decimals later. And 3. At 3, we've got 9/5, which is 1.8. Now, for the decimals and fractions, I'm going to hit the table button again, hit enter again, but this time instead of auto, I'm going to use ask x. Okay, so get over there and hit enter. So now it's going to ask me for the values I want. So I want to do negative 2.5, so I'll do negative 2.5 and hit enter. So I'm getting 25 over 9. Okay, I'm going to toggle that. That's positive 2.8. Okay, and then negative 1.5. Okay, so negative 1.5. So I'm getting this. That's negative 1.3. And then 2.5. Well, there's that 25 over 9 again. Alright, again that's 2.8. Wait, did I do negative 1.5? I must have spaced out. Negative 1.5. That's negative 1.3. Alright, what about positive 1.5? Did I maybe I wrote it in the wrong spot. So at positive 1.5, it's also negative 1.3. Okay, so it's negative 1.3 all places. So we have this entire table of values. Let's just go ahead and graph all these points and see what we've got. I'll do that off camera. Alright, so when I plot all of these points, this is what I get. And that gives me a pretty clear picture of what's going on here. It's going to be like this. Okay, and then here it's doing like this type of a thing. Alright, so your graph should look something very much like this. Now the domain. Looking at the x values from left to right, we're going to have each one of these branches is going to give us part of the domain. So this branch right here, remember only x values please. This branch goes from negative infinity to negative 2. So negative infinity to negative 2. Union. The middle branch goes from negative 2 to positive 2. Negative 2 to positive 2. And the last branch goes from 2 to infinity. Okay. Now the range. The range goes from bottom to top. And we're looking at all the y values that are covered. Now look at this bottom part, which is the first part that we come to. Alright, this little loop down here, it goes from negative infinity up to 0. So I'm going to put negative infinity up to 0. Now so far I've been using round parentheses because these were all asymptotes. And you can never get to the asymptote, so for that negative 2 I would leave it round. But this is not an asymptote right here. Okay, it gets to 0, it touches it. Alright, we have a point, it's right there, 0, 0. So 0 is included in the range. So I need to put a square bracket on that guy. Okay, and then there's a gap here. There are no y values between 0 and 1. Alright, so we're not going to pick up from here with another 0. The rest of the graph starts after 1. So the rest of the graph is going to go from 1 to infinity. Okay, just beyond the asymptote on up. So that would be my range, domain and range. Now let's talk about increasing and decreasing intervals. So as I trace the graph from left to right, I need to think about where am I going, uphill or downhill. So from left to right, this part of the graph goes like this. Whee! Up. So that's an increasing part of the graph. Alright, so remember, I just want x values, okay? So this over here is negative infinity. Now this right here is not positive infinity because I'm talking about x values. This is negative 2. Okay, the x value of this position is negative 2. So we're going from negative infinity to negative 2. And this is increasing. So my first increasing interval is from negative infinity to negative 2. Okay? Then, next we arrive at this part of the graph right here. So from here to here, it is increasing. You know, let me change colors here. So, so this part of the graph down here, don't say negative infinity because we're doing x values. This position right here is negative 2. So from negative 2, alright, to this position right here, which is 0. So from negative 2 to 0, we are increasing again. From left to right, this is increasing. So negative 2 to 0 is another increasing interval. Okay? But then, as it continues from there, from 0 to 2, and again, this position, don't say negative infinity, I want x values. So this is 0, x value, and this is an x value of 2. So from 0 to 2, we are now decreasing. Okay, so that's a decreasing interval from 0 to 2. Okay, and then the next thing we see as we continue to go from left to right is we get to this branch right here. And from left to right, this branch goes down. Okay, this is a decreasing interval. Now, so it goes from here to here. But I want only x values, please. So the x value of this position is 2. See it? X value of 2. The x value of this position, don't say 10, this is an arrow. So the x value of this position is positive infinity. So from 2 to positive infinity, the graph was decreasing. Okay, so that's another decreasing interval from 2 to infinity. Alright, so basically the left half of the graph is increasing, and then the right half of the graph is decreasing. Okay, symmetry. This is one of the rare graphs that actually has symmetry. This does have, because the y-axis forms an axis of symmetry, this function is even. Alright, even symmetry. Okay. That is plenty of video for just one problem. So I am going to stop this video just with number 7. If you are copying along and copying off of me, you will not learn anything that way. So please, you need to make sure you can do these problems by yourself. Otherwise, when the test or quiz comes, you're going to fail that thing and wonder why. Alright, copying is the reason why for those of you who say, I do all my homework, but then I fail the test, I don't understand what happened, Mr. Burton. Well, that's what happened. You quote unquote did your homework, but you actually were just copying off of me the whole time. So you don't learn anything that way. So watch the video, but do the problems yourself, please, afterwards. Peace out. See you on the next video. Okay, from here we're going to number 9. I don't know what happened to the number, but I'm pretty sure this is number 9.